All right, good morning, and today we are talking about reflections. Okay, we're almost to fall break, but this is our final lesson before fall break. Then we'll review a little bit these next 2 days. And a reflection, many of you probably already know, like when you look in the mirror, you see that reflection, okay? And in our case, it's not a mirror, it's going to be a line, but it's some sort of transformation that will be across a line. And I'm going to make that a little bigger for you. There we go. Okay, so it's a transformation across a line. And many of you know, like whether it's a mirror or a window or a puddle in the street, as you lean closer to that reflection, okay, in the same way kind of with this video. As I get closer, I can see my picture gets closer to me. So as you reach out towards that mirror, it looks like you are reaching out towards yourself, the reflection is. Okay, so the line of reflection, I'm going to call it a mirror in quotes because it's not really a mirror, but it acts like a mirror. Okay. Now, this transformation across the line, if we think about it, the original shape we know from when we're talking about translations is our pre-image. Pre means before. The result or the reflection is our image. Okay. So we're next going to look here, and if we have the generic point xy, so xy, I'm going to show you 3 different examples of this point. So let me pull up my sketch pad. Okay, so if I have, should have done this before, sorry, just the standard xy plane. So our x and our y axis. And I have some generic point over here, xy. If I reflect, for this first one, we're going to say, if we would reflect over the x-axis, what will happen to that point? Okay, so if we reflect over the x-axis, we hopefully know that our x-axis is right here. It will end up down below here. Now, if we think about it, the x value does not change. X means left and right. That is the same amount to the right, so x will be exactly the same. I'll put x. Meanwhile, y goes from y to negative y, okay, because it was up, now it's going to be down. So the value here is going to be x comma negative y. Now the next one, what if we would reflect it over the y-axis? Okay, so same idea. Over the y-axis, it started here, it's going to end up on this side, and that the x value will switch, so negative x. The y value stays the same, it does not change in height, so negative y. So the final one, sorry, I misspoke, negative x and y. Okay, now the final one we're going to talk about is what if it's reflected over the line y equals x? Now, this line y equals x, some of you might be thinking, what is that line? If we think y equals mx plus b, there's no b here, which means it's 0, so it goes through the origin. M is what's in front of x. There's nothing there, which means it's a 1, so a slope of 1 through the origin. Okay, so this would be a line like this, right through that origin. So if it has the point xy, so say it was the point 3, 2, then it would reflect and end up at that point 2, 3. So the x and the y switch places. Okay, they will switch places, and it becomes yx. So using that knowledge, if we have the point 2, 5, it's reflected in the x-axis, so the x value stays the same, the y value goes to the opposite. The next one, y equals x, so they're going to switch places. The third one, negative 1, negative 7, over the y-axis, the x will change, the y will stay the same. The final one, over the line y equals x, they will switch places. Even though there's a decimal, it's the same exact rule. So now, that's how we kind of do it when we're just talking about it. but sometimes we're going to do it graphically. So if we need to reflect over the x-axis, first thing we should do is draw in that x-axis. So right there, that is our line of reflection. And we said as I get closer to the mirror, my reflection gets closer. So likewise, A, if we think about it, it's 1, 2, 3, 4 away. Now some of you might have counted that and counted the starting point and got 5 away. But if we think about it, when you come home from the hospital, right, you are not 1 year old. You are 0 years old. It's not till you finish that first year you turn 1. So in the same way, we can't start with 1 here. It starts at 0. Then it's 1, 2, 3, 4. Then we just go 1, 2, 3, 4 past. And that will be A prime. B is 1 away, so 1 past, B prime. C is 1, 2, so 1, 2 past, C prime. All we got to do is connect our dots then, and this is our line of reflection is the x-axis, and it reflects over that. You see if we folded on that line of reflection, it would match up. Okay. Now, that's pretty easy when we are given the x or the y-axis to flip it over. Sometimes we'll ask to graph the line y equals -3 and reflect over that, or x equals 2. Now, these are hard. You're going to think y equals, you're going to think it goes up and down like the y-axis. Y equals -3 actually means it cuts through the y-axis at -3. So right here, it will cut through. So that is our line for y equals -3. Now we're going to do a dotted line at x equals 2. It will cut through the x-axis at 2. So 1, 2, I guess I don't need to count. It goes through 2 there. And that is our line x equals 2. So probably the hardest part is finding that line of reflection. Once you got that, it should be pretty easy. Reflecting across y equals -1. So we go through the y-axis at -1. So I'll do this in red. The y-axis here at -1, it's going to cut right there. So how far is E away? 1, 2, so 1, 2 past, and that is E prime. L is 1, 2, 3, 4, so 1, 2, 3, 4, L prime. And D is 1 away, so 1 past, that is D prime. Connect our dots, and we are done. Now the next one, x equals 1. So I'll start by drawing my line of reflection here through the x-axis at 1. And on this one, 2 of the points, just the same. Z is 1, 2, 3 away, so 1, 2, 3, Z prime. H is 1, 2, so 1, 2 past for H prime. Now, B and S are on it, but think about it. If I reach forward and touch, right, you can see in the picture, if I touch the mirror, it looks like I am touching, okay? My reflection looks like I'm touching my finger. So those points are right on the mirror. The reflection is also right on that line of reflection. I need to relabel them as S prime and B prime, and then we can draw our line in, and we are done. All right, the next one, y equals -2. So drop down 2. That one will go through the y-axis at 2. Oops, let me fix that. I was off a little bit. And D is touching once again, so it stays there, D prime. J, you know, is 2 away, so 1, 2 past. M is 1 away, so 1 past. Draw in our shape, and we are done. Now the last one that we are going to draw, x equals -2 goes right through that shape, which some of us might be a little confused by. It's okay. A would be 2 away here, 1, 2, so it goes 2 past. Now the good thing about these lines of reflections, they're not like a mirror. They can go either way. So J is 1 away. It will go 1 the other way. And L is on that point. It will stay there. Kind of looks like a spaceship here. It can reflect either way on the line of reflection. And we're almost done. The final thing we're going to talk about is the line of symmetry. These lines of reflections are like a line of symmetry. If we fold the whole graph over that line, it matches up. So a line of symmetry through this oval, we're going to have one right here, one right here, and that is it. So 2. Through our pentagon, one right here, that's the easy one. Lots of you might think that's it. We can go through all of those corners though. Oops, that's bad. So there's actually 5 lines. In the octagon, you can go through each of those corners. You can also go through each of the sides. And we're going to get 8 lines of symmetry. If you have any questions, let me know. There is a Delta Math assignment, so please get that done. Hope you guys have a great day, and I'll see you later.